Good morning everyone. Today we are going to discuss about the topic that is deterministic and random signals. I am Dr. Abhishek Joshi. I will be discussing about the course Digital Communication, that is KEC 601. So the textbook which I am following to prepare the notes is the John G. Process by Digital Communication, that is the 5th edition of McGraw-Hill, and other textbook is BP Lathi. So these two books I am referring to make our lecture notes. The other three books which we can refer is Top Shillings and Singh and Sapre and John G. Process. So these are the reference books, that is a short outline series, Bernard Sklar and Simon Hackens. So these are the reference books which you can refer further for digital communication for the course KEC 601. So the contents which we are going to discuss in our first lecture is the meaning, the nature, objectives or scope, use or applications. So what is the meaning of digital communication? So it's a two word which is having digital plus communication, which is making a digital communication. So what is digital? So before starting we must understand what is digital. So digital can be defined as of a signal or data expressed as series of digits. This is series of digits such as zeros and ones, typically represented by values of physical quantity such as the range or the magnetic polarization, or you can say the voltage. And how we can define communication? Communication engineering is the process of conveying information from one place to another place. It may be through via electrical or electronic means, using some components, device or equipments and processes from the source, which is actually a transmitter, to the destination. So that we are using in terms of the transmitter and receiver through some channel or the medium. So channel can be wireless channel, channel can be a wired channel, or we can call it as a guided channel. So what is the nature of this subject? So when we are discussing the digital communication, so it's a operation or working or purpose wise it belongs to the communication engineering. So first we have to understand what is communication engineering, then only we can understand what is digital communication. So construction wise, as per use of components, equipments and system wise it belongs to the electrical engineering, but in overall conclusion it belongs to the subject that is the communication engineering category. So what are the course objectives and the course outcome for this course? So we'll discuss at the end of this course, students will be able to demonstrate the ability to formulate the basics for statics involved in the communication theory, to demonstrate the concepts involved in the digital communication, this one, and to explain the concepts of the modulation schemes, to analyze the performance of digital communication systems, and last one, to apply the concepts of information theory in digital systems. Now what is the syllabus for this course? Syllabus is for the unit 1 is as follow, that is the deterministic and random variable, or you can say the random signals. So first we will discuss with the types of random variable, that is our today's topic of this lecture. The type of the random variable discussed today. Then we will discuss about the cumulative distribution function and probability density function. Then the standard distribution, Gaussian or exponential, that is a Rayleigh, uniform, Bernoulli's, binomial and Poisson's discrete, uniform and conditional distribution function of a random variable, means, variance, moments and characteristics function. So these are the content for the unit 1. So in our today's lecture we will be discussing about the types of the random variables. The content for the unit 2 is as follow, that is the band pass and low pass. So these are the digital communication and modulation basics, so we will discuss these. Introduction to digital communication systems, PSD of line coding schemes, pulse shaping, scrambling, high diagram, Gram-Smith orthogonalization procedure, that is the scheme which we will discuss, and the digital modulation. So in digital modulation again we will discuss about the modulation and demodulation of digital modulation schemes such as ASK, that stands for amplitude shift keying, FSK, that stands for frequencies shift keying, and PSK, that stands for phase shift keying. Well, we have the DPSK, that is a differential phase shift keying, and the QPSK, that is a quadrature phase shift keying, and the constellation diagram. Introduction to M-array communication. So content for unit 3, we have the digital communication through band limited channels, characteristics and signal design of band limited channels, optimum receiver with channel, and AWGN, that is a linear equalization, decision equalization, adaptive equalization, and introduction of multi-channel and multi-carrier systems. Okay. So we have unit content for unit 4 as the optimum threshold detection, concept of matched filter, because in receiver we want to reduce the noise. So in case of digital there is no noise, there is error. So we have to analyze the receiver for its performance. So for matched filters we are going to optimize the receiver. Then we have the BER analysis for BASK, BFSK and BPSK signals. Spread spectrum signal for digital communication. So the model of spread spectrum, that is digital communication, that is also known as SSS or SS DAC, that is a DSSS, direct sequence spread spectrum signals, or also known as DSSS, and frequency hopped spectrum signal, that is FHSS. So these are the spread spectrum techniques. The last unit of the syllabus of the course is dedicated to the information theory, because we know that bits which is transmitted are in the form of ones and zeros. So if bits are transmitted in form of ones and zeros, then we have to take into account the error, and that error, how we can correct the error, how we can detect the error, and all these schemes come under this information theory. So we have the measure of information, entropy, mutual information, mutual entropy, source encoding, that is a Shannon-Fano and Huffman coding we have discussed, and the Shannon's channel capacity theorem, information to error correction and detection, linear block codes, cyclic codes, so that is a systematic and non-systematic, BCH, that is a Bose-Chaudhary codes, Reed-Solomon code, introduction of trellis and graph based codes, that is a convolution coding and decoding. So this is the entire syllabus of the course which we have discussed. Now what are the applications of the digital communication, where it is used? So the applications we find in telecommunication, that is internet. So internet we are using these, and the best and the economical means of long distance transmission. So all those data applications where large bandwidth and very high data rate is required for fast communication with less number of errors. Now what is the concept of probability? So before starting with a random variable, we must understand what is the probability and what are the keywords which defines the probability. So what is an experiment? So experiment is nothing but is used in probability theory to describe a process whose outcome cannot be fully predicted, because the conditions under which it is performed cannot be predetermined. with sufficient accuracy and completeness. For an example, tossing a coin is an experiment, rolling a die is an experiment, drawing a card is an experiment. An experiment may have several separately identifiable outcomes. So what are the outcomes? The results of the experiments are the outcome. So we can understand that, for example, rolling a dice is an experiment, but having 6 outcomes is the number of outcomes of experiment. And what is an event? An event is a subset of outcomes that share some common characteristics. For example, getting an odd number for an experiment, that is rolling a die, is an event of getting odd number of ones, that is 1, 3 and 5. For example, getting an even number when we are throwing a dice. So what we'll get? We'll get 2, 4, 6. That is a subset of all the outcomes, but it will be considered as an event of getting an odd number, even number, or you can call it as in different ways or different examples. For example, if you are drawing or if you are throwing 2 dice at a time, so getting a sum as an odd number, getting a sum as an even number, so these X events you can consider as an event. So let's start with our topic, that is the first topic of this unit, that is unit 1, that is a random variable. So what is a random variable? So if there is m sample, so we have m sample points, that is eta 1, eta 2 up to eta m, then using some convenient rule we assign a random variable x that is having all the outcomes, or you can say all the sample points eta I, to sample points, that is eta I, that is I equals to 1, 2 up to m. In case of tossing a coin, for example, we assign the number 1 for the outcome heads and the number -1 when the outcome is tail. So we can define this in terms of the probability. We are having the probability of getting -1 and 1, that is 0.5, but we know that the summation of the probability is equals to 1. So 0.5 plus 0.5 will result you 1. So thus the x, which is a function of, that is mapping the sample points, that is eta 1, eta 2 up to eta m into real numbers, that is x1, x2 up to xn. We now have a random variable x that takes a values, that is x1, x2, x up to xn. So these random variables are nothing but a variable which is consisting a subset of all the outcomes of an experiment. Okay. So we shall use a Roman type x. So we have to define the random variable with some variable x to denote a random variable, and the italic, so we can use italic terms, that is x1, x2 up to xn, to denote the values it takes. The probability of a random variable x taking a value x1 is x, that is xi, and the probability is given by x equals to xi. So we will call the probability of a random variable, that is equals to the probability of xi. So now we will define, because the random variable can be continuous, random variable can be discrete. So first we will define the discrete random variable. So a random variable is discrete if there exists a denumerable sequence of discrete numbers, that is xi, such that, so for example tossing a coin, so what are the probabilities of getting 1? 1 by 2. What is the probability of getting 0? 1 by 2. And we know that these are the two discrete numbers. So these two discrete numbers, if we add, we'll get the probability, the summation of the probabilities of the two random variables, that is px, that is x1 plus x2, will get 1. Okay. So we can define in terms of the summation, that is I. Okay. So in case of tossing a coin, so we have two outcomes, head and tail. Okay. So I is equals to 2. So we have the probability for x, that is xi, that is 1 by 2 plus the probability for 1, that is 1 by 2, the summation will result you 0. So, in a formal definition or in a formal formula, we have the summation I px xi equals to 1. Now, the discrete random variable. So, random variables x and y. So, how we can find the joint probability? So, the joint probability of the two random variables x and y is the probability that xi. So, this x is a random variable and this xi is the value of the random variable, while the y is a random variable and its value is yj. So, consider for the example the case for a coin tossed twice in succession. So, we are tossing a coin, that is twice. If the outcome of the first and the second toss are mapped into the random variables and x and y. So, these are the two, you can say, events, that is in subsequent. So, first event is the random variable x and the second event, or you can say the upcoming event, is the random variable y. Then x and y takes values 1 and 1 because the outcome of two toss are independent and x and y are independent. So, these are the two independent events. So, how we can find the joint probability? So, for these two events we can find the joint probability, that is the probability of two random variables x and y, that is xi comma yj. So, we can write, if these two events are independent, then we can write, that is px of xi multiply with py of yj. And if we want to plot or if we want to represent the joint probability of two random variables, we can define in terms of a space that we have the x as a random variable and y and another coordinate, and we can plot the probability in terms of this dotted line, dashed line, okay, having these values in terms of head and tail, having the values 1 and -1 respectively. Continuing with this, so we can find that the probability for getting 1 and 1, so probability of getting 1 and 1 is equals to the probability of getting 0 and -1, then the probability of getting -1 and 1, then probability of getting -1 and 1, so -1. So, the overall probability is all are equal because of the independent events, and we are getting probability as 1 by 4. For a general case where the variable x can take value, that is x1, x2 up to xn, the variable y can take values y1, y2 up to ym. So, we have summation of I, summation of j, that is p xy, that is xi comma yj is equals to 1. So, this follows from the fact that the summation on the left is the probability of union of all the possible outcomes and must be unity for a certain event. Let us take one example. So, example is two dice are thrown and the sum of the points appearing on the two dice in a random variable x. So, we are considering a random variable x when we are throwing two dice, and this x is a random variable which is having the sum of the points. So, whatever points we are getting, where x is the sum of points. So, find the value of x and the corresponding probabilities. So, this we have to find the probability for a random variable x. Now, how we will solve it? So, using the previous formula we have, I will show you again, we have the summation, as we can see here, the summation of the probability is equals to 1. So, we will verify this also using this example. Yes. So, how many possible summations are there for when we are throwing two dice? So, the possible combinations, the sum will be 1 1. So, minimum value in a dice, we can see the number dice having the 6 faces, and these faces are numbered as 1 to 6. So, minimum value is 1. So, 1 and 1 addition we are getting 2. So, we have 1 plus 1, that is 2. We have another number which we can get in the first dice we are getting 1, second dice we are getting 2, or we can get first dice as 2, second dice as 1. So, the summation will be 3. Now, what is the out of overall possible combination? So, how many possible sample points are there when we are throwing 2 dice? The possible sample points are 36. So, probability of getting 2, the sum as 2 is 1 by 36, because overall points are 36, or overall sample points I must call, that is 36. So, 1 by 36 we are getting. For a random variable, or that is sum is 3, we have 2 possible points, that is 1 comma 2 and 2 comma 1. So, the probability will be given by 2 by 36, as we can see here, and it is getting 1 by 18. So, the fourth, what is the sum? How we will get 4? So, we can get 4 when we are throwing 2 dice. We have 1 comma 3 and 2 comma 2 and 3 comma 1. So, we have 3 possible combinations through which we can get sum as 4. So, we have 3 possible combinations. So, probability will be given by 3 by 36. Similarly, for 5 we are getting the 4 combinations, that is 1 comma 4, 2 comma 3, 3 comma 2 and 4 comma 1. So, these are the 4 possible combinations. So, we are getting the probability as 4 by 36, it is 1 by 9. Similarly, how to get the sum as 6? So, we have 1 comma 5, 2 comma 4, 3 3, 4 2, 5 1. So, the probability is 5 by 36, because we have 5 possible combinations. Okay. So, how we will get 6, 7, 8, 9, 10, 11, 12. So, we can collect all the points, and we can find according to the number of points we can calculate the probabilities, which are as 5 by 36, 6 by 36, 5 by 36, 4 by 36, 3 by 36, 2 by 36 and 1 by 36. So, if we add all the probabilities according to the formula or according to the theorem of probability, we have, that is summation of all the probabilities for all the random variables is equals to 1. So, if you add all the values, you will get the probability for the random variable, that is the sum of the numbers when we are throwing a dice, 2 dice in random experiment, will get 1. So, next topic is conditional probability. So, what is the conditional probability? Conditional probability comes under that the one event has been occurred. So, what is the probability of the second event? So, how we can calculate it? So, this conditional probability solves this issue. So, we have, if x and y are 2 random variables and the conditional probability of x, that is xi, and y is equals to yi, is denoted by, that is probability that the event y has been occurred. So, what is the probability of x? So, it is given by p x by y and the values, that is xi and yj respectively. So, moreover, we can write that for the conditional probability, again that the summation will be equal to 1. So, we can write the summation of I when event y has been occurred. So, what is the probability of x? That is equals to the summation of the probability of y by x when the event has been occurred, it is equals to 1. So, this can be proved by observing the probabilities, that is p x by y, that is xi by yj, are specified over the sample space corresponding to the condition, that is y equals to yj. Hence, the summation, that is probability x by y, that is xi by yj, is the probability of the union of all possible outcomes of x under the condition y is equals to yj, because x and y are the 2 random variables and must be unity, a certain event. And a similar argument applies to the summation, that is summation j p of x by j by xi. So, we can write the conditional probability as the p of xi by j, that is equals to the conditional probability, that is Px by y and Pxi by yj multiplied by the marginal probability Py yj, that is also equals to the conditional probability of Py by x, yj by xi, and the marginal probability multiplied as Px xi. So when applying the Bayes rule, so we have the Bayes rule given by P of xy, that is a joint probability xi and yj. So we can apply the Bayes formula as you have studied in the probability. So we have this probability of conditional probability P x by y multiplied by the marginal probability P by j. Again we can write, or we can take the summation as Py by yj summation I P of x by y and xi by yj. So this is nothing but, because we know that the summation of this probability is equals to 1, so we can simply write the joint probability is nothing but is equals to Py yj. Similarly, we can prove it for that marginal probability P of x, that is equals to summation of Px by xy, that is a joint probability, that is equals to 1. So the probabilities, that is the Px xi and Py yj, are known as the marginal probabilities. So using the Bayes rule, we have solved it and we have proved it in our previous slide. So these Px I and yj, this yj and xi are nothing but the marginal probabilities. So equation shows how to determine the marginal probabilities from the joint probabilities. Results equation through can be extended for more than 2 random variables. So in our lecture we have solved for 2 random variables. Further you can apply the Bayes rule to expand it for more than 2 random variables, for example 3 variables, 4 variables, 5 variables. It depends on you how many variables you want to take into account. Let's take an example. So we have a binary symmetric channel, that is a BSC, that is having the error probability given by PE. So we are getting error probability PE. The probability of transmitting 1, because in digital we know that either we can transmit 1 or 0. So the probability of transmitting 1 is Q, and that of transmitting 0. So what is the probability that we transmit 0? If you have the probability transmitting 1 is Q, so it is 1 minus Q obviously. So determine the probability of receiving 1 and 0 at the receiver. So we can draw a diagram in terms of the input. So what we can draw, that we have this x equals to 1, that is Q, and x equals to 1, that is 1 minus Q, that is transmitting a 1 and transmitting a 0. So we have defined ones and zeros as we can see from the figure. So we have the probability of error. So we have transmitted 1 and we have received 1. So what is the error? The probability of error we have defined here is as PE. So without error it will be 1 minus PE. We have transmitted 1 and we have received 0. This means there is an error. So what is the error? It is PE. Again, for example, we have transmitted 0 as you can see and we are receiving 1. This means the probability will be 1 minus Q, and if we are transmitting 0 and we are receiving 0, then we have the probability that is 1 minus PE, that is the probability of error. So how to solve this probability? So determining the probabilities for 1s and 0 respectively. Here we can see for x and y are the transmitted digits. So for 1 and 0 we are designating it as x and y, and the received digit respectively then for the binary symmetric channel, because we are calling it as binary symmetric channel. So either you will receive 0 or either you will receive 1. You will not receive 0.5, you will not receive any other values. Okay, so because we are considering binary symmetric channel, so both are having the equal probabilities. So we can write the conditional probability that x has been received, okay, that is 1 has been received what is the probability of getting 0? That means there is error, that is we are designating it as PE. The probability that X has been received and Y has been transmitted. So, we can write the values as 0 has been received and 1 was transmitted. So, again we have the probability of error because we are getting error. Similarly, for no error, it is nothing but 1 minus PE, because the summation of the probability, the maximum value is equals to 1. Now, this Py by x, that is 0 by 0, Py by x for 1 by 1 means you have transmitted 1 and you have received 1. You have transmitted 0 and you have received 0. Here you have transmitted 1 and you have received 1. So, this means you have to subtract the probability of error from overall probability, that is maximum value is 1. So, 1 minus PE. Similarly, here we have P of x, probability of x, for transmitting 1 and receiving 1 we are getting Q, and for 0 the probability is given by 1 minus Q. So, according to the probability theorem which we have derived earlier in our previous slides. So, we have the marginal probability of y, that is equals to the marginal probability of x multiplied by the conditional probability of y by x. So, we can find the probability of 1, we can find the probability of 1 as the marginal probability of getting 0, that multiply with the conditional probability of 0 has been received and 1 was transmitted, plus the summation we are getting the marginal probability of x, that is 1, and x has been received, that is 1 has been received and 1 has been transmitted. This means we are having 1 minus PE, and this P of x for getting 1 is Q, and here for getting 0 we have the 1 minus Q, and y by x for there is error. So, we can get the similarly we can find for getting 0. So, what is the probability of getting 0? That is 1 minus Q, 1 minus PE plus QPE. So, these are the answers, seems almost obvious from the figure. So, in earlier slides I have shown you the figure and we have derived it and we have solved the probability of receiving ones and zeros respectively. So, what are the remarks for today's lecture? So, we have discussed, we have introduced the probability and the random variable, and in detail we have discussed about the discrete random variable. So, here we stop our lecture. Thank you.